on you, because you have to know how to do quadratics, you have to know how to factor, you have to know how to do trinomials, you have to know how to get rid of radicals. The trig part is my concern here. When you get down to the trig part, that's the part that I want to focus on, because the rest, that's algebra. You should know how to do that. So let's discuss this. Again, isolate your radical. You can't square this until you isolate your radical. Square both sides. Anybody have a problem up to here? Up to this 4 cosine squared thing? Okay, so we got to solve for this. We divide by 4. We've got to square. We take the square root. We get a plus or minus. Separate this. If you don't separate this, it's not going to look like a special right triangle to you. Radical 3 over radical 4. Yeah, I recognize those sides. So I drop one triangle. I figure out my reference angle. My reference angle opposite the 1 is a 30. If you don't know that at this point, you're in serious trouble. So that goes into 186 times. And did I say between 0 and 2 pi? I just wanted the 4 answers. However, because you squared something, if you square a negative, you forced it to become a positive. So we learned this when we did absolute values and when we did radicals. So check your answers. Just put it in your calculator. Put it in your calculator and check. So you plug it in and you find that you have to reject these two. Now, 7 pi, 5 pi, and 7 pi. Right in here. 5 pi, 5 pi and 7 pi. These guys right here. Does this make sense? Wait, give me 1 second. This is 5 pi and 7 pi over 6. Does this make sense that if I rejected this one, I would reject this one? Why? They're both negatives. So these are both positives, these are both negatives. Look for those. If we square a negative, we force it to become positive. It may not work when we put it back into the equation. Question. Wait, I'll take Amanda.
I know, like, for some of them that we did before, you, like, when you had all 4, you took a line through, like,
But this one, yeah, you only needed to find a solution between 0 and 2 pi.
So you only do that when it's 4?
When it's all solutions. When it says all solutions, then I'm going to do the plus and pi. But on something like this, I kind of have to narrow it down because you do have to reject some.
Okay, and then when it says, like, solve, you don't do plus and pi plus square pi.
If it says solve,
Yeah.
usually I'll tell you to solve all solutions or solve within a certain domain.
Okay.
Like if you got down to here, technically you could do this angle plus 2n pi, this angle plus 2n pi. That's all solutions because these will never work.
Mm-hmm.
But if I'm doing something where you're going to reject it, I'll usually just do it to like 2 pi.
Mm-hmm.
Usually.
I don't understand how you want to reject 5 pi or 7 pi.
Because we have to test it. Because sometimes when we have a regular equation, when we had regular radical equations and we did this, Amani, we put it here and we squared it. If that came out of there a negative, I can't have a negative coming out of there, I forced it to be squared. I forced it to be positive by squaring things. I square this right here. This guy is I'm not worried about, but this is probably the guy that I'm going to have to worry about. When I look at the cosine, and if the cosine is negative, what am I forcing it to be? When I square it. Positive, right? Because otherwise, if this guy was negative, could a radical ever be equal to a negative? So if I get this angle and my cosine is negative, all you got to do is really plug it right into here. If I took the cosine of 5 pi over 6, I don't care what it is, but it happens to be negative, could my radical ever be equal to a negative? If I'm checking it. Because the cosine of an angle will be negative in 3 and 2 and 3. Yeah, and that's all I rejected, 2 and 3. Because look what happened. If my cosine of 5 pi over 6 is a negative answer, could this radical ever be equal to a negative? Without the square. Before I square it. It can never be equal to a negative, but I squared it. When I squared it, didn't I force it to become positive? So this will be true over here. But when I go back and check it, these two I have to reject. You did this when you did radicals. When you did radicals and absolute values, way back like September, October when we first did this. We said every time you square a radical, make sure you check it. Every time you do things with the absolute values, make sure you check it. because this can never be negative over here. This is the only guy you really have to check for. Just make sure you check. Just plug it into your calculator, throw your calculator in radians, and plug it in. Okay, find all solutions. This is where your 2n pi or your n pi is going to be, because this says all solutions. So we're going to have to get rid of these and reject it, and then give all solutions.
Why did you even put all of them? Like, why did you even list them out?
Oh, because when we first do this, it covers all 4 quadrants. However, you squared this piece right here. Look, watch. If I take this equation, and I just move this to that side, what can come out of this? A positive or a negative? A positive. Only a positive can come over here, right? Can never be negative coming out of my radical. Agree? What can come out of this? Anything. A negative or a positive, right? I don't say where it's coming from. I just say the tangent of any angle. So which angles do I have to worry about? The angles that have what kind of a tangent? A negative. If my tangent comes out to be negative, could this ever be true? Whatever the answer happens to be, could it ever be true? No. So the only ones I have to reject are the angles whose tangents are negative. So when I come down here and I build my 4 quadrants and I say, okay, tangent is negative where? In 2 and 4. Aren't I rejecting my angles from 2 and 4? All the time, right? Which ones am I keeping? Without doing the words to it. Which ones am I keeping? I'm keeping this one and this one. So now my all solutions can only be this guy, this guy, this guy, this guy. So here I'm across the pole. All I have to do is list this guy and say plus n pi, where n is any integer. Because now, every time I hit this one, I'll hit this one. I don't want these negative guys. They won't work. I forced them to become positive when I did this. I forced it to become positive. Well,
wouldn't you, like, undo that at the end when you take the square root?
Absolutely. Absolutely. I did. I undid it at the end and I took the square root. But I really can't use those negatives because, look, if my tangent of x ever says negative when I plug it back in here, will it work? It won't work. Agree? Mommy, do you see it?
Why did you put it? If it's supposed to be plus n pi, why did you put n pi over 6?
Well, if you wanted to look at it this way, and you were doing all of these plus 2n pi plus 2n pi, if you looked at this plus 2n pi and looked at this plus 2n pi, you'd come back here, but do we have to do this? On the cosine, we had to. On the cosine, we had to because it was here. That's where it was positive. So this guy, you had to do plus 2 pi. This guy, you had to do plus 2 pi. This one is tangent, and tangent has a period of pi. So I only have to do it this way. Cosine, we had to do, if it said all solutions, we would have to do this, plus 2n pi plus 2n pi, because of where the cosine's period is 2 pi, and because of where it falls. But you can condense this to this one.
Do we have to condense it? That, I don't get that.
The ones that go right across the pole, they go right across the origin.
No, I know, I get that part. I just don't get, like, how it breaks down into just x equals pi over 6 plus n pi.
So, because if you find this one, and you add 2 pi, you keep coming here, coming here, coming here, right? Then you add this one, you keep getting 2 pi, 2 pi, 2 pi. You always get this. If you take this and just go 180, you get this one. 180, you get this one. 180, you get this one. Because you're straight across the pole. 180, 180. So all you have to do is give me this one plus 180. But if that works for you, that's fine. Especially on these. Because what happens to the cosine, you have to say plus 2n pi. The tangent, the period is pi. This is part of working with radicals and absolute values and things like that. As soon as you do something, you manipulate this, force a negative to become a positive. If I, in fact, get a negative, it's not going to work. I had to do that to solve the equation. What are these guys called when we reject these? Extraneous roots. That's why these are called extraneous roots. They work in my algebra part, but when I plug them back in, not feasible. Same thing when you have a rectangle, and you say this is whatever, and you make a quadratic, and you find the area to be 24 or whatever, and it comes down to x equals 4 and x equals negative 2. And what do you do with the negative 2? You reject it because you can never have a negative in there. But didn't you have to solve it as if it would be regular? Yeah. It's the same process. As soon as you square something, check it. As soon as you work with absolute values, check it. Who still doesn't get this? Who doesn't get this?
I don't get this one. Oh, I did not get this one.
It's because the half.
Wait, which one is that?
Yeah, this one was hard.
Oh wait, let me see.
Okay,
Oh, I
so
got it. Let's go.
what does this represent when we did this? We said it's a half angle, right? So take it out and put x in there for now. Just remember what we did when we were doing these in class? We took it out. If you don't have this, make sure you're writing this down. Okay, now, I still maybe don't see this. So let me just take this out. Let me take out cotangent, because that's really confusing me. And let me look at it like a regular quadratic. So now can I factor this guy? To what? X plus 1, x plus 1. Do I have to do both of these? X plus 1, x plus 1? No, just do one of them. Okay, so x is equal to negative 1. But now my x was really, what was my x? 1/2 x. So I'm just going to replace and put my 1/2 back in here now. And what was my x representing? Cotangent. So I have 1/2, sorry, cotangent 1/2 x is equal to negative 1. I still am going to leave my 1/2 there for a minute. I'm going to find out where is cotangent negative 1. We got an all solutions? Okay, let's do an all solutions. Where is cotangent negative? Oh, wait. I hate working with cotangents. Let me work with the tangent. Let me just work with the tangent. I like that better.
Wait, if you do that, don't you have to put 2 over 1?
No. Where do you flip? What's its trig ratio? This. That's its trig ratio. What's its trig ratio? What is the cotangent of this angle? This. This is what you flip. So, it's still going to be negative 1. I'm okay with that. I like that better. So now, I say, in my quadrants, Chris, where is tangent negative?
Negative and 2 and 4.
2 and 4. So I'm going to draw a triangle in 2 and a triangle in 4. And I'm going to label it. What is my reference angle? 45. How many times does 45 go into 180? 4 times. So if this is 4 pi over 4, what is this angle right here? 3 pi over 4. Now, if I get to this, can I shoot straight across this? Half of a circle, half of 2 pi, and get this guy? Half of 2 pi and get this guy? Yes? So plus n pi, where n is any integer.
Wait, where'd you get the 2 on?
I didn't do the 1/2 part yet. I didn't do the 1/2 part yet. We're just finding the angle. We got to find the angle first.
So you
Where is this angle? Well, regardless of what this says right now, where is this angle located? Here and here. I'm not doing the 1/2 yet. Don't put the 1/2 in if it doesn't help you yet. Just find me what angle has a cotangent of negative 1. Where is this? 2 and 4. Agree? So maybe now put the 1/2 in. Let me rewrite this over here. So far I look like this. Hang in there. So far we look like this, right? Did I use the 1/2 yet? No, because it only names my angle. It doesn't name my ratio. It doesn't help me find out where it's supposed to be. I don't need the 1/2 or the 2 or the 3 until the very, very end. I got to go through this whole thing as if this is one angle. Now we got this part. Now let's throw the 1/2 in here. So just like in algebra, if I have 1/2 of x and I have to solve for x, how do I get rid of that denominator? Multiply it by 2. I could divide everybody 1/2, but this is easier just to multiply by 2. So I take this guy, multiply by 2. I take this guy, if I multiply this by 2, this gives me 6 pi over 4, which reduces to what? 3 pi over 2. I don't care where this angle is. Let's see if it makes sense in a second. I multiply this guy. I'm still n is any integer. Now, let me see if this makes sense. I have 2 angles in 2 pi. I'm a half angle now. I expect half as many. How many angles in 2 pi should I find? 1. If I was this angle right here, now let me just call this in degrees for a second. This was our 3 pi over 4. This is the same as 135 degrees, right? So if I'm only expecting one of those now, it's kind of like doubling this angle. Here's 135 times 2. Oh, isn't 3 pi over 2 270? Yes. Does it make sense? So, no. This is what I'm looking at. This guy. Let's worry about 4 pi in a second. All right. So say what bothers you. And memorizing. What happens to memorizing is when the situation changes and something else like the 1/2 throws you off, you don't know what to do with it. If you just remember the 1/2 is an angle, not a factor, not anything else, take it out. Okay, this guy, can everybody factor this? X squared minus 1 minus 1 is 1x minus 2. Take it out if you have to.
Why did you return?
Well, because my sine curve goes from 1 to -1. So it only goes as, well, there's my 1, there's my -1. It only goes as high as 1 and as low as -1. Could I ever find an angle that has a 2 in it? So I'm not really sure. So I'm going to pull up my calculator and I'm going to see. So I'm going to say second sine. Do I have an angle whose sine is 2? Whoops. There's my calculator only works. Do I have an angle whose sine is 2? No, you do not. Because the highest the sine goes is 1, and the lowest it goes is -1. So I don't have an angle for that. I just made my life real easy.
I just did the triangles and I saw that 2 is across from the angle.
And absolutely, if that's a perfect way to start too. So sine is positive here and here. So if I say y, my y is 2 and my radius is 1, is that a possible triangle? No. So therefore, can't do that one. Sine is -1. Oh, that must be my quadrant angles, because sines and cosines and zeros and ones are my quadrantal angles. So I again map them out, and I say, where do I see that at -1? Right here. So if I only have one angle in 2 pi, how many should I have in 4 pi? 2, because I had to reject the other one. So I should only have to come around this again. So I could take 3 pi over 2 and add 2 pi to it, convert my denominator, and say, oh, yep, that gives me 7 pi over 2. Or, because I'm only doing this one more time, just keep running it by halves. 4 pi over 2, 5 pi, 6 pi, 7 pi. Yes.
Why is the denominator 2?
Where? The 3 pi over 2 or here?
And then 3 pi over 2.
Because your sign says, find me, it's a 0 or a 1. So when I lay this out,
The triangle, it's just on the...
we'll try to make a triangle out. Let's try to make a triangle out of this. Good point. Let's try to make a triangle out of this. Where is my sign negative? 3 and 4. So I make myself a triangle. And I say, okay, I got a y,
What's 2?
2 and 3. 3 and 4. Thank you. I have a y over an r. So if I put this here and I put this here, how can I have a hypotenuse be the same as my leg? The only how I could do that is when this comes down here. Watch. Because when this comes all the way down here, isn't this my hypotenuse as well as my leg? So as soon as I draw my triangle, I say, I can't have a triangle that has a 1 as a hypotenuse and a 1 as a leg. That's why don't memorize. Make sense out of these.
Yeah, no, this one makes sense.
Makes sense, right? Sorta.
The last one's the only
Wait, so
one. Yeah,
I'm so
number
confused with how the denominator is
6
2.
and 5.
Because what is that angle down here? 3 pi over 2. 270. And what is 270 in radians? 3 pi over 2. Amani, watch. What is 90 in radians? So let's count. 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, 5 pi over 2, 6 pi, 7 pi over 2. Just keep counting. Just count. Okay? Find off solutions. I know this one had to throw you off for a loop.
No, this one is
This one was easy.
Nope.
easy. Yeah, I like this one.
Okay, so let's walk through this. Give me your attention so we can walk through this. I've got a sine and a cosine. Nah, not happening in one equation. That's like an x and a y in one equation. I can't do that. I have one Pythagorean identity that this is the one I have to memorize.
That's the only thing I would like to say.
This is the only thing you have to memorize. And actually, you don't even have to memorize it because this is your x, this is your y, this is a 1. Miss Imperiali had a joke. Did she tell you her joke? About sine squared and cosine squared? Probably because trig wasn't too funny for you guys last year. So sine squared walks into a bar and he sits down and he meets the person next to him, and the person next to him is cosine squared. So he says, oh, sine squared and cosine squared, together we make 1. Remember each other, together we make 1. So if that helps you memorize it, it's something like that. I probably ruined her joke, but it's something like that. But this is the one, Pythagorean's identity. And then you put your cosine in, and then you put your sine in. So make sure you know that identity. You can't break down cosine, only sine squared. So replace it, substitute it in terms of cosine. Now the rest, excuse me, make sure you distribute a negative. Make sure you collect everything to one side. This guy is your leading term. Make sure it stays positive. If this was negative, get rid of the negative. Divide by a -1. Don't factor when this is negative. This is an easy one to factor. You only have 2 factors of this. So if I started this like this, I'm just going to put an x in here. The last thing I do is multiply, right? I need to get a positive when I multiply. But when I add, I need to get a negative. So what are my signs? Negative, not negative positive, because then that would be a negative. Negative, negative. That makes my life very nice. So now, there's only one set of factors for 2. I'm going to plug in a 2 and a 1. I just have to work with this guy and this guy. This is my smile. I have to put a 3 and a 1 in there so that I come out with a 7. So I'm just going to plug them in right now. I'm just going to plug in a 3 and a 1. This will give me a -3x. This will give me a -2x. Did I make -7? So what do I have to do? Just switch this. 1 and 3. Maximum 2 times to get there. Maximum. Can you do a times c?
Yes.
Absolutely. A times c, that works. Again, just let me hit this one second. Again, we're going to reject this because this is out of our domain, out of our range here. We don't have an angle whose cosine is 3. Cosine is 1/2, positive here and here.
You know that you don't have the 3 because it's cosine?
Because cosine and sine only go up to -1 and +1. If it was cotangent or secant, yeah, I do. but not cosine of sine. And between 0 and 4 pi, I would just keep your pattern going. Just, if you want, add 2 n pi to both of these. I would just keep your pattern going. If this is a 60-degree angle, 3 pi over 3, 6 pi over 3, 9 pi, 12 pi. Let me just move this up so you can see the last one. Sure, I'll send it down. Chris, Miss Gutierrez at the guidance. Miss Gutierrez Cologne. No, in 1 minute. Ah, this is it again. This 1/2 is an angle.
I know, but I'm thinking about that 1/3. I thought things was randomly smaller than a whole.
So the tangent is y over x. There's no hypotenuse in tangent. Tangent is opposite over adjacent, y over x, no hypotenuse. Okay, now this one, guys, yes, this one was different. If you didn't get finding the angle, I'm not concerned about it. This is the only one that wasn't your special right triangle.
Yeah, that's why I didn't.
Yeah, I threw that in so that you would see that it is possible we don't get a special right triangle. On the test, you're only getting special right triangle. Also, listen, I'm going to post the answers on that photo to that second sheet. So my advice is work on it first and then look at the answers. You have all weekend to do it.